So here we got a dividing two rationals together, and so what we have to do is we have to perform by flipping it here, multiplying by the reciprocal. So the things that we talked about, in addition and subtraction of rationals, whenever we're doing those, we have to have common denominator. That's the concept we need to know. Whenever we're doing multiplication and division, we need to be able to multiply and factor. If you can multiply things, then you should be able to divide them, because division is going to turn into multiplication. So since this is division, what's going to happen is we're going to take the numerator, we're going to keep it, we're going to multiply by the reciprocal of the denominator. Can anybody remember why we do that? Say what now? We're trying to cancel out this. Okay, so I'm going to show you a little generic picture of it. If I had this situation of a number A divided by a number B, and then that all is divided by C and D, then what we have to do to wipe out C and D to make it one fraction is I have to multiply the bottom by whatever C and D are, because those are going to cancel out, make 1. If I do it to the bottom, I now have to do it to the top, so my division became a multiplication problem. That's the reason why. Okay? So you need to know why we're doing it and not just performing an operation that I say, hey, if you want to do this, do this. This is the reason why. Okay? And so in here, really what we're doing in multiplication, we're not multiplying anything till the end. We're looking to eliminate and cancel out factors. And so what I can do is I can factor by canceling up and down. Does anything cancel here in this one? The n does not cancel. Once again, this is how I want you to see this. Does this work? Well, let's do it like this. Can I cancel that and get the same answer that if I added 5 plus 3 and divided by 3? I can't. Well, that's the same thing we're saying to do, that if I can cancel the n's right here, I'm taking a sentence of a mathematical expression and I'm canceling out a piece of it. The only thing you can cancel are factors. Right, and so this n plus 3 can cancel with this n plus 3 because we can cancel up and down or across, not directly across, okay? And so I can cancel 1 of the n minus 1s, correct? The square root. The square, I did, because I mean this is really written as n minus 1 times n minus 1, so I really just canceled one of them. So if I cancel the square, I know there's one left. Okay? Now I can expand it and write it like this anytime I want, if you need to see what you're actually canceling, but I canceled that, canceled one of the 2's, that means I'm left with one still there. And so what am I left with that's going to be my answer? N minus 1 over n plus 2. Now, in the worksheet that we worked, which we're going to talk about this in the graphing concept, I'm telling you right now the restricted value here would be negative 2. Can anybody tell me why?
Since we flipped it, we have to give the opposite?
No, it has something to do with the denominator, but we'll get into that in the graphing. The restricted value here would be negative 2. Where does a negative 2 look like it would go?
In the n plus 2.
And what would happen if I put negative 2 in for n
It'd cancel out.
and make a 0? How many of you can divide by 0? You can't, because it's undefined. So that's why negative 2 is a restricted value, and we'll talk about that role further when we get into the graphings of these. Okay? Any questions on that one?